Okay, hi guys. In this video, I'm going to teach you how to find the area under the curve. I believe you have ever counted that there is a thing we call area under the curve and area under the line. But in this tutorial, we are going to learn how to calculate the area under the curve. And this question has been extracted from past year and we'll be doing that. Okay, as you can see now, we have a curve here. This is a cubic curve. But this part, there's no area here. So there's a shaded area right below here to this point here. So this point is very crucial and we need to find this point. Okay, one thing we can know is that the question already given us, there's a point here 40. I assume the 40 has to be here. Reason because why? They already specify it's a minimum point. So you know cubic curve is always in this form, a S shape. So that means there's a maximum and minimum point. So definitely this 40 has to be here. This is the minimum point. So if you want to find area under the curve, we need to make sure our limit starts from 0 all the way to 4. Okay, that's one. Okay, now let's see first the first part. What they ask you, show that the curve has a minimum point at 40 and find the coordinates of the maximum point, meaning they want to know this coordinate, both of the coordinate. So how actually we go about it? Okay, first step what we do, we extract this equation. First I'm going to write here y equals to x cubed minus 8x squared plus 16x. So now that I write that, I'm going to go and differentiate it. Okay, I'm going to differentiate it because they want me to prove that this is a minimum point. So 3x squared minus 16x plus 16. So you have to remember, at all these minimum points and maximum point, your dy dx will always be 0. So 3x squared minus 16x plus 16 equals to 0. And you further factorize it. After you factorize it, you should get x minus 4, 3x minus 4 equals to 0. Okay, so you solving this will give you x equals to 4 and x equals to 4 over 3. So it makes sense a lot. So 4 is here, 4 over 3 here. So now we want to prove this point. One of them is minimum, another one is maximum. So to prove maximum minimum, you need to do double integral. So I will just do it here. Okay, I'll write there to prove max and min. Okay, so I'm going to do double integral here. Integral from here, so double integral to d2y over dx, so 6x minus 16. So now in my double integral, let's substitute this value. So x equals to 4, therefore 4 minus 16. Okay, 4 minus 16, 6 times 4, and you compute, you will get 8, which is more than 0. So if a value of double differential is more than 0, that means it's a minimum graph, which is already proven. Now we want to prove for the maximum. So for proof the maximum is the same, x equals to 4 over 3. So 4 over 3 minus 16, and you compute, you get negative 8. Negative 8 means less than 0. So less than 0 means it's a maximum. So we already proved that this is minimum, this is maximum. Okay, that's done. Now let's look at the next part. Okay, the next part they said, find the area of the shaded region. Remember I already told you the shaded region limit is from 0 to 4. So we just use this equation, we integrate it, and then we can get the area under the curve. So I'm going to show you area equals to your integral 4 to 0 x cubed minus 8x squared plus 16x. So I'm going to integrate this x power 4 over 4 minus 8x cubed over 3 plus 16x squared over 2. Okay, so the limit is 4 and 0. So now that we've done this already, all we have to do is substitute. So 0 you don't need to substitute because 0 will give you 0 back. So I'll put here 4 over 4 minus 8 4 cube over 3 plus 16. You can simplify this if you want. Okay, I don't see the need in that. So I will just show you minus 0 just to fit the calculation. So with that, you compute, you should get 64 minus 512 over 3 plus 128. I already pre-calculated, okay? So that's why I do it fast. So 21, 1 over 3. That's the area. And remember to write units. If you don't write also, it's fine. So what are the important things that you need to know in this type of question is, remember, area under the curve, you always must integrate, okay? But if you want to find maximum, minimum, then you differentiate. So integration, we only use for one thing. In your syllabus we use for two things, which is to find SVA. Remember SVA, kinematics, or we used to find the area under the curve. And then on top of that, you also must remember to prove a point is minimum or maximum, the method is by double differential. So what's the purpose of first differential? First differential just to serve only to find the gradient or to find the stationary point, because stationary point and gradient is basically the same thing. Okay, so the first differential is to find either gradient or stationary point, and meanwhile the second differential is to prove whether a point is minimum or maximum, and the last one, if you want to find the area, make sure you log the limit first. Okay, so thank you for your time for the video. Bye bye.